is a co-founder of Mydbops. Myself, as she told, I'm a senior DevOps and DB consultant at Mydbops. You can reach me through the link, email or Twitter. And it's a little glance about Mydbops. Mydbops is a database consulting company. We are the motto, we are evolving the DBA consulting through the DevOps model, and we are helping organization to implement and scaling their DB in their infra. We are founded in 2015. We are having a 25 people set of employees, and all senior DBA or certified people, and we have a lot of cloud certified employees in our organization. So we have a list of happy customers. They're great, like Quicker, Swiggy, Razorpay, or our customer. We are helping the customer to scale. So right now we are supporting for Flipkart to scaling their DB. Everyone know they are having big billion days. So the topic about the agenda of the topic is how DBA top responsibilities before and after the cloud. After DBAs come, how DBA need to evolve themselves and help the organization, and what are the fascinating feature which is provided by the DBAs, and where DBA skills are needed and where they need to evolve themselves to help the organization, and in simple topic, how to choose the right vendor, what is the capacity planning and cost management, what is the DBA role, and we are going to share a great experience use case for you, and then conclusion. The simple thing, everyone know what is the top DBA responsibility before cloud. Everyone know, right? It's just installing, configuring and patching the DB server and reacting to the DB issues and tweaking the DB configuration, taking backup and restore. This is very normal, every DBA do in their life before the cloud. The thing is, after DBA, the DB as a service come, everything is under the scope of DBA. What people can't believe, so everything is provided by the cloud, what DBA will do in the organization? That is the biggest question mark right now in the market, and lot of startup is thinking we don't need a DBA. Not like that. So before going to answer that, I like to share what are the fascinating feature which is provided by DB as a service. Elasticity, one of the great feature. You know that we can provision our IOPS whenever we need, and we can resize the instance, and we can add the read replica, we can add the load balancer. One of the very great feature for the startup company right now is they can use the multi-availability zone options, cross-region replica, and scale out globally. These all very great feature right now provided by the cloud for the companies. So let's come to the question. Do DBAs eliminate the need of DBA in the cloud? No. Till it is needed by every company. Till every company need a DBA. So how DBA need to evolve themselves and help the organization? This is the main scope of the topic what we are going to discuss. Support on choosing cloud vendor. So when you are choosing a cloud vendor, I can see we are working on a lot of migration activity. They are in the physical infra, they are moving from physical to the cloud. They are blindly choosing some XYZ cloud vendor. But there are a lot of parameters need to be considered. That is very important point. What are the cloud vendor we are having before that? As a DBA service, everyone know AWS, Microsoft Azure, Google Cloud, Alibaba, ScaleGrid, Compose. These people are providing very good DB as a service right now in the market. We are not marketing them, we are just naming few of them. These are very key feature, key parameter we are using to suggest our client when, in what cases you need to choose what provider. The important point is DB super user access. Not every DB as a provider is not giving a super user access for the DB as a service. But you need any use case you are having, you need certain constraint in your application or in your use case, you need to consider this parameter and you need to select that DB as a provider, such like SSH access, such like plugin extension, such like in most of the cloud DBS, we are providing instance class or type. You can choose that only. That like you can increase your RAM or disk whenever you need. But some of the, for example, I am directly pointing the vendor. Sales grid is giving option to increase your RAM and disk whenever you need. You don't need to switch one instance type to another instance. This like feature you can use, but you need to choose the correct vendor. This is very database feature control and replication topology. Not every vendor is providing all replication topology. You need to consider that parameter before choosing the replication cloud vendor, and custom replication set config. This is one important thing which is given by AWS. You can click and create a read replica in a simple second. In simple click, you can create a read replica in the huge production case, or you need to scale in something like some event is happening in your company or something like that. Another very important thing is backup and security. Three important things in backup and security: custom backup, selective restore, and point in time restore. The thing is, the difference between selective restore and point in time restore is, selective restore you can select certain table to restore or certain database to restore. Point in time restore is like git commit. You can go to any version of your database, any point in time in the database. So this is a great feature which is introduced in Amazon Aurora. So this like feature, if you need to do certain vendor and you need to go for such type of services. And another thing in the security perspective is encryption at rest. This is very important point. Lot of healthcare company, lot of insurance company are moving toward cloud right nowadays. But what they believe the unsecureness is, how can I keep the data in the cloud? Okay, in communication we use TSL or SSL. What about the disk? How can I believe the cloud, or how I believe that my data is secure? So there is a great feature which is right nowadays providing by the cloud vendor is encryption at rest. While the data is in the hard disk, the data is encrypted. So you can make sure the data is encrypted, so it's not able to read by anyone other than your application or yourself. So it is a great feature. You need to consider this all parameter. What I'm trying to say is, you need to make a note and make a list before moving from one cloud vendor to another, or you are moving from local infra to your cloud. Support and monitoring. This is related to the managing of DBs. Every cloud provider will have a DB server log, but most of them is not giving access for the log. So you need to make sure, so you are going to manage a cloud RDS or Aurora or Google SQL, so you need to make sure you need access log, they are providing or not. Make sure that, then move to the provider. So monitoring, CloudWatch is, in AWS CloudWatch is providing the monitoring at certain level. They are not up to the level, but they are providing few parameters. For that, other than that, you need to pay something. So you need to handle the slow query log, you need to monitor and configuring and the tuning. This all things need to be considered before choosing a vendor, cloud vendor as your DBA provider. Cost planning, capacity planning and cost management. It is very, 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 very important for us, because what people think, they didn't consider any factor. According to our experience, we are working for a lot of clients. They didn't consider, they just push their local infra to the cloud at any cost of instance. I will share a simple example. Most of the application developer won't close the connection properly. In my experience, it will open lot of connection. If one connection thread is handling this much memory, so calculate the QPS and how much memory we are allocating for the thread. So this like scenario will happen. When you are going for the proxy SQL kind of thing, the proxy SQL give query cache option. So lot of select query will be answered by your proxy. It won't affect your master server. So this LA place, load balancer place will serve, you are filtering lot of connection, so you can write lot of input to the master server. So the design factor, when you are going to design your DB infra, you please make sure how your production is, how we are going to share the load between the master, slave, load balancer, everything. So this is very important thing. So I will, next my colleague will take over.
Thanks Manoj, that was a great explanation, and from now I will take about the next important task of a DBA. So the next important task of a DBA is database schema design. So the schema is nothing about the data type which you are choosing to store your data. So you should be always aware of the data limitations. For example, if you're using a text column or a blob column, whatever the case, if you're using a text column, it goes for a disk-based scans or a disk-based temp table. So it is a limitation. So you should avoid using a text column or a blob column. So, and always try to use the right engine for the right use case. For example, if you're using a OLTP kind of a workload, InnoDB will be your best choice. And if you're using a read-based, more kind of read, you can go for a MyExam engine. And the partitioning is not a DBA activity. That means, so the partitioning has to be done at the design phase itself, not letting your DBA to say that the table has been grown much more and we need a partition. The partitioning at the end has a drawback, like you have to take a downtime, rebuild the entire table, and then create the partition and maintain the partition, and it has a lot of overhead. And get the normalization right. So at the first instance of design, get your normalization right, so that can efficiently manage your database. So the next important task is the query optimization. The most work done by your database system is the queries. So you make sure that your queries are being optimal and runs in a very faster manner. To make the query faster, you can have the indexing based on the query pattern and the query analysis. So don't blindly go and add an index for all the queries. Adding too many indexes can also slow down your queries because the index page has to be updated for all the incoming writes. So next important thing is that the complex queries, for example, the complex queries and the frequent queries can be rewritten as a SP, that is a stored procedure which can be called very easily from the application. The composite keys are very much beneficial because they have the ordering of the index. For example, if your var class has, it is AND condition of 3, where ID is equal to 1 and the name is equal to 3, add a composite index on the high cardinality number, that is a ID first and the name next. Okay. So next, a subquery. A subquery is a great performance bottleneck inside your DB. Subquery is nothing but a query inside a query. So the total execution of the query depends upon the result set which is given by the inquiry. So make sure to have a smaller subquery or avoid the subquery. The subqueries can be easily written as a join. So the next important thing is the long running query. For example, in case your analytical query comes to your DB, in that case it makes a lot of scan and it also has a tendency to make the locking. So that can be evidently viewed in your process list. Just get all your long queries, profile your queries, and make sure that is indexed, or make the analytical query on a different DB box or a reporting box. So next I'll jump into a use case. So this is a production use case. We have worked with one of our client. So the X is our client. They are doing a business of e-commerce on beauty and the cosmetic products. Okay, this is a technical stack and the database I'll just explain. So they are on the Amazon RDS 5.6 and the data size is around 288 GB and their max QPS is 50K, and their IOPS, they were using IOPS of around 6K, that is a read IOPS of 4K and a write IOPS of around 2K, and the CPU spike and the usage was around 85%. This was the previous stats what I am sharing, and this is a technical stack and the instance type. Master, it is a R4 16x large, which is the largest instance in the R4 family. As you can see, the CPU is 64 and the memory is 488 GB. As you can see, the data size is just 28 GB. This is a over provision system. So you can just fit all your data into the memory. And the disk is, they have a disk of around 1000 GB. So with the standard EBS of the RDS, they give a 3 IOPS per GB. So the standard EBS supports a 3000 IOPS. Even with the 3000 IOPS, they have over provisioned a provision IOPS of 5000 IOPS. The next is a read replica. The read replica is the next instance type, that is a R4 8x large, which is 244 GB RAM. They have a replica of 3. Okay. So even with this larger system, they had a problem like slow response from the DB, and the CPU usage in the DB boxes getting spiked to 85% at a peak sale, and unable to handle the peak load, the DB crashes and it goes for a failover kind of a thing. And there is a high connection usage due to the locking and due to the long transaction which is going inside the DB. Okay, this is their architecture. Master is multi-AZ on a different availability zone, and these are the 3 read replicas. The master is of, as I said, it is R4 16x large, and the replicas are R4 8x large. Okay, so this is a cost estimation which is taken from AWS cost calculator. So the first, the R4 16x large with multi-AZ, it's come around $13,000, and the next is the 3 read replicas which comes around $9,800, and the provisioned IOPS which they have provisioned for all the servers, that is the 4 servers, which is $2,490, and they are also on the enterprise support for AWS, which is $1,500. So okay, so this is a sysbench test on the instance type which they are using. I'm just presenting a slide to show the capacity of the server which they are using. So as you said, as already said, the CPU is the 6432 core, and the CPU speed is around 2.3 gigahertz, and their anticipated write QPS with the sysbench test is 82K for the master and the 74K for the slave, and anticipated read QPS for the master is around 1 lakh QPS, and the replica is 74K, and the mixed load of the read and write is around 91K for the master and 75K for the replica. So this is a very generic benchmark via the sysbench. Okay, now let's come to the problem, that is slow writes. So as you said, RDS is a DB as a service. So when you move to the DB as a service, they does not give all the tuned parameters, that is the parameters based on your workload. So this is one of the important parameter, that is the InnoDB log file size, which controls the size of the redo log or the recovery log. So this is a transaction database. So whenever a write comes, so the database should make sure the write is durable. So it writes to a redo log. So when the transaction size is, the default transaction size is 128 MB, okay, and as you can see the red lines, so it is a circular log with 2. So our redo log size is around 256 MB, and our incoming writes, so the average incoming writes of our DB is 1.72 GB. That means it is exceeding our log file size. So whenever a write comes, the write has to wait for the logs to get completed and then written. So this is causing a commit latency on the DB. So the writes were completely slowing down. So these graphs are taken from the PMM, which is an open source tool, and we have analyzed the DB. So our writes were at 1.72 GB or the 2 GB. So this has to be normalized, or the logs has to be made free to accept the incoming writes. So we made a decision to increase the log file size from 128 MB to 2 GB. That is a combined size of 4 GB to handle the incoming writes. So this is not a dynamic change. This change requires a restart. So this was added to the parameter group, and a record downtime was asked from our client. Then we restarted the server, and after that, all the writes, the incoming writes were scaled, and they were no commit latency, or the writes were scaling well. So and the next important problem, so we have now solved the write or the commit latency issue. The next is the read latency, or the reads getting slowed down. So always we believe that the 20% of the queries, that is the top 20% of the query, is the 80% resource consumption queries. So we just focused on the top 20 queries which is incoming to the server. So and this is also a snippet taken from the query analytics which comes along with the PMM. So we just concentrated on the top 20 queries for tuning. For example, the queries were profiled against a test instance. We got a test instance from the client, just it's not a bigger instance, just a smaller instance. We profiled all the queries, that is what is the pattern of the queries and what is the query count, how much is the query, this query hits in a per minute or a per hour. Based on that, we ranked the queries and profiled the query in the test instance and proposed a new index and also there were some queries which cannot be tuned, okay, and they were using a wrong functions, wrong joins. So for example, left joins could be very much expensive. So whatever the possible ways, the left joins were rewritten as an inner join for the performance benefit. So we provided them the report, like these are the indexes had to be added into your system to increase the performance, and these are the list of the duplicate indexes. As I said, the duplicate indexes can slow down the writes. So these are the list of duplicate indexes, and these are the list of the query rewritten things that has to be taken care from the application, because we cannot do any rewrite. So this rewrite has to be come from the application end. So once applying all these indexes and removing these duplicate indexes, the problem of read getting slow was completely away, and this provided a drastic improvement in the resource consumption. For example, the CPU usage completely came down from 80% to almost less than 30 to 40% for the same performance. Okay, and these are some other parameters, that is the supporting parameters that were tweaked along with the redo log file size. Okay, so this is a past, present, and the future expectation of the current system. For example, the past it was scaling for 50K, now for 50K, but let's see the CPU percentage. Initially it was 85% and the DBA was not scaling and it was trembling, and you can see now at the present with the 40% of CPU usage, you can achieve the 50,000 QPS per second, and also the IOPS. So since the index were added, the IOPS usage on the disk access has been completely eliminated, and the IOPS usage came from 6K to 2.5K. So, and the future expectation is without scaling further, that is with the same instance, they can grow till 80 to 90K with the CPU usage of 65 to 75%, and with the IOPS bustable capacity to 8K. So what we changed here? So we changed nothing in the architecture. We just reduced the instance size from R4 16x large to the R4 8x large on the master, that is with the multi-AZ, and R4 8x large on the slaves to R4 4x large. So that is a 50% reduction in the instance type without compromising the performance. So next is so again I'm coming back to the AWS cost calculator for the current instance. So as you can see, the 8x large with multi-AZ is $6,566, and the R4 4x large is $4,924, and the provisioned IOPS was allocated only for the master, and it was removed completely from all of the slaves. So it is just one. For 1000 IOPS we have $996. So this was their previous cost, that is for the R4 16x large and the R4 8x large, their cost was around $40,000, $472, and this is a new cost after reduction. So as you can see, the storage cost completely came down, and the database cost is around 11,000. The total is around 12,000. From $40,000 per month to we have reduced their instance size to $12,000 per month, which is a $27,000 gain for them. So,
do you have any queries on other DB?
No, whatever.
Actually, what we are trying to say in this use case is the default parameter won't help you at any time. The art is what people believe when you go for cloud as a DBA provider, we just put the DB and we can push the application, point the application to the DB, then job is done. No, it is not. What nowadays people doing, people throwing money to the cloud provider and getting the instance, upscaling their instance size. That is very, very bad. That's what we are trying to help. So the thing is, you need to narrow down your issue, and you need to point the issue and fix the issue. Then, before scaling, you need to ask yourself what we said. So why we need to scale? What is the current usage pattern? We are spending this much money. What we are achieving is nothing. What every people doing in the cloud is they are upscaling their instance. Any issue they got by the night time, they just upscale the instance because it is easy. Elasticity, the great feature provided by the cloud is elasticity. They just upscale. With blindly they are upscaling. So you see, two parameters, simple two parameters save 27,000. It's not easy per month. It's not a year also. It's a per month. So there are a lot of things need to be considered. For MySQL, we are saving. We have a lot of use cases also. I like to share only few minutes. For one of the company, e-commerce company we work, they are in RDS. They are having 1 lakh IOPS. Not simple. 1 lakh IOPS. 1 lakh IOPS. They are having 4 read replica. They have a maximum average query in all server. For some server, RDS server, they are getting 1000 IOPS. Some server, they are getting 400 IOPS. Some server, they are getting 200 IOPS. The problem is they are asking us why it is happening. We are having all provisioned IOPS are same, all DB size is same, maximum query is splitted equally, but why it is happening? The problem is the block level. The block, right? The disk is block. The data is storing in disk block only. In some RDS, they are having 4 block size. Some have 8, some have 16. So you see, if I need to fetch a 2 byte of data, how much time I need to have a IO there? Here. So it is different. But you are paying for IOPS, not for a block. So the lot of things need to be considered, and you need to evaluate yourself. You need to check why we are having this issue, whether we are doing correctly or not. No, we are not. We are just helping to scale MySQL and Mongo.
That's true. My question is,
Yeah, I understand.
cost-wise, have you done any comparison? If I take database as a service, right, there is certain cost. Same thing if I take a cloud server and install my own database inside the cloud server and do things. So how does it compare?
Yeah. See, I'll explain with the AWS itself. In the AWS, we have 2, that is the EC2 and the RDS. The RDS is a DBA service, and the EC2 is a elastic compute which they provide. You have to install your MySQL and provide that. So the cost comparison, as you can say, is the EC2 RDS is 30% costlier than EC2, than maintaining your own database.
So do you suggest better to do the EC2?
It's on the cost perspective part, EC2 is better.
And it provides more flexibility also,
Yeah,
right?
more flexibility, and you have control over your OS and also your DB, full control over OS and DB.
Okay, thank you.